We don't have a lot of time today, so we're going to jump into it. Chapter 4, we talked about lots of trig stuff. Yeah, kids? Mm-hmm. Talked about the unit circle all the way up to inverse trig, all the way up to crazy right triangle problems, the graphs, etc. You guys can tell what regular pre-cal is doing. They have a little quiz on chapter 4B. They took a chapter 4A test. They're not going to even have a chapter 4B test. And then they're going to finals. Yeah. Today, probably around 5. I have a mission meeting at 6, but I might need to run off campus.
Are the tests already available for us to see?
We have 2 people still needing to finish it tomorrow. They're starting today, but it's a short day. You can peek at how many multiple choice you got. Right. Won't say wrong. So then chapter 5 is basically more trig, but we're not learning graphs, we're not learning unit circle, we're not learning exactly what is a radian and how does it compare with degrees, etc., etc. We're just kind of using it. So do you guys remember in section, I think it was 4.4, how I mentioned the t-proof? And it had to do with showing that one side equaled the other, and I was like, hey, it's coming back. Guess when it's coming back?
Wow.
Except, that's actually section 5.2. Section 5.2, we're going to go in more depth with how to do those t-proofs being about, which, if you guys remember from that homework, was there just one way to do those? Or is there sometimes more than one? Right? Yeah, Sean's like, yeah, I spent a long time on one that I did fast. Anyway, he did a good job at it, or on it, but he went a different direction. You just have to keep it legal. That's actually section 5.2. Okay, it's going to have us combining like terms. It's going to have us foiling. It's going to have us factoring. It's going to have us playing around with trig expressions, trig identities, trig formulas, so that we have the foundational skills to go to 5.2 and to be able to see what we can do to change the one side to make it equal the other. So we've kind of had an introduction to that, showing that one side equals the other. However, we're going to go ahead and in 5.1, remind ourselves, /practice, /follow really explicit, really direct directions that will tell us exactly what to do, and we'll see how the different math that we do with the trig allows it to change, to transform into different expressions. Now, first of all, do you guys remember Pythagorean comes from, long story short, unit circle? Do you remember, we have x and we have y, right? For any point x, y. Do you remember which side goes along with cosine?
Adjacent.
Adjacent, or the x, right? The x coordinate from the unit circle with the hypotenuse of 1. And which side corresponds with opposite, or what? Where does the Pythagorean property come from that you guys either just wrote down or just gave a page number to yourself to review? And what is the formula? Sine squared x plus cosine squared x is 1. Right? Which comes directly out of the different identities. The different identities from before. Now, do you guys remember, because I'll be back in just a second, do you guys remember that we can actually rearrange that basic formula? So not only can we use this formula to say, hey, if we see sine squared plus cosine squared, we can substitute for 1. It's so much easier. But we can also see a sine squared x and substitute, or see that it's equivalent to what expression? How about cosine squared? I want you guys to go ahead and use the properties that you just wrote down, or maybe you have to turn to that page number. I want you to try to rearrange and say, okay, what could I say is tangent squared, and what could I say is secant squared? Does anybody have an eraser real quick? Because I can just go on. Are you here? She hold on to it and finish this up? Alright, what'd you guys figure out? Oh, sorry, not secant squared, tangent squared, and cotangent squared. What could tangent squared equal?
Sine squared minus
No, not
secant squared.
secant squared. There we go. What could cotangent squared equal? Cosecant squared. Real quick before we move on. Did I already show you guys? I don't think I did. How you can use sine squared x plus cosine squared x equals 1. How that's the fundamental identity and you can use it to find the other two. Since we're talking about transformations and math that you can do with trig identities, the very first Pythagorean, now hold on, go ahead and look at your formulas real fast. The very first Pythagorean is sine squared x plus cosine squared x is 1, or maybe it could be cosine squared x plus sine squared x is 1 because addition is commutative, right? But what's the next Pythagorean identity? Good. 1 plus tangent squared of x is equal to secant squared of x. Huh. What's tangent? Just plain old tangent equal to tangent of x? Sine over cosine, right? Huh. What if I was to divide the sine squared by cosine squared? Ooh, that'd be tangent squared. Hold on. That's not legal right now, right? My equation is horribly imbalanced. How do I fix it? How do I make everything still be equivalent? Okay, that's better, but I'm still off balance.
But we're just supposed to only work on that side.
But we're not doing t cubed yet. Hold on.
Okay.
Couldn't I divide everything by cosine squared? Now, use your identities. Luke, what did you say a second ago? Sine squared over cosine squared could be tangent squared. If sine over cosine is tangent, I could pull that little squared out. Sine over cosine is tangent, bring the squared back in. Plus, what's cosine squared over cosine squared? What's anything over itself? 1 equals, what's 1 over cosine squared? Secant squared. Hey, what? Is that the other formula? Maybe it's a way of remembering if you forget. Divide everything by cosine squared to get one of them. What do you think we're going to do in the next one to get the other one? Because there's a second formula, right? Or a third, I should say. Divide everything by sine squared. Everything's balanced. I should say my equation is still balanced. The equality is still there because I divided every piece. It's technically both sides, but the left side has addition, so we need to divide both pieces of that side. What's sine squared over sine squared? 1. What's cosine squared over sine squared? Cosine over sine is cotangent. Pull on that squared. And 1 over sine squared is cosecant. Remember, reciprocal of sine cosecant, reciprocal of cosine secant. Only one in code. Only one code per reciprocal identity. So if you ever forget, this is a little discovery, I guess. It's one of those if we had time back when we first talked about it. I remember we were running short on time. So I thought I'd show it to you now. Okay. Anyway, we have identities and we have rearrangements of identities. We've reviewed how to, or maybe we've seen for the first time where these other ones came from, besides just memorizing them. But now we got to use them. Now, you don't have to be creative this section. Not really. You don't have to be creative this section. You get to follow the directions given to you just to see what you can do with the math at hand. And the math at hand, or I should say the trig expression at hand, the directions say factor and then simplify. So they tell you to factor. Next section, you're just going to have a t-proof and you have to figure out what direction you can go. See if it works, and if it doesn't, backtrack. Let's try another approach. But this section, follow directions. Simon says factor. What are you going to do? Factor out what? Don't factor out an x. Remember, he's an argument. He's stuck. There is no multiplication of tangent times x. It's tangent. But I can take tangent.
It's like 1 minus sine. Tangent outside, 1 minus sine.
You gotta take sine out.
You guys are making it too hard. I wouldn't be taking sine out. I would just say, who's the greatest common factor? There's subtraction. There's two pieces. The greatest common one is tangent squared. Yeah. That x has to come along with them, right? If I just write tangent, it's like me just writing this in a problem, and you're like, huh? What are you doing? There's nothing inside. Exactly. Write the argument. Okay. What's left when you pull them out of each piece of the binomial? Okay, the directions say factor and simplify. Is that simplified? Maybe, but I don't think so. But we have to think, is there an identity that we can use to go further? Oh, we just wrote it. 1 minus sine squared is?
Cosine.
Cosine squared. Here's a rearrangement with the binomial. Oh, we're done. Can't go any further. Wait, can it?
Yeah, we can.
Tangent is sine over cosine. Tangent squared is sine squared over cosine squared. Now, some of you might stop a little early. You might not realize you can keep going. That might be one dilemma that you face in homework. But kiddos, why is it so important to keep going? Can't you reduce? Not technically canceling. What do you have left? Now, could some of you have thought you should have stopped here? Maybe. Or there? Maybe. Or there? Well, that was the end. What's going to be one hard part of homework?
You really know when to stop.
You don't really know when to stop. Now that's the nice thing about section 5.2, because section 5.2, remember, it gives you both sides and says, okay, show. So you know the beginning, well, you choose a side, and then you know the end. So you know when to stop. This section, the directions are easy. They tell you what to do, factor. Then simplify. What's going to be tricky is you're not exactly sure when to end. So just go as far as you can, keeping everything legal. Don't go doing some crazy stuff like throwing in opposites and hypotenuses and never go back to sides. Not when we're dealing with identities. But isn't that something also odds? Check the back and see how far they want you to go. Yeah? Calc chat, you can check your steps. And then evens, we'll just see tomorrow. We'll just see tomorrow how far you should have gone and see if you thought it through the same way as the answer. Luke, go ahead.
Could you get to that answer in like one step by taking tangent as sine squared of x over cosine squared of x and then factor the sine of all three of those? And then the 1 over cosine squared of x would cancel and it would just give you sine squared.
The problem is with that one, you would have had a sine squared here and a sine to the 4th bit. So that would have messed it up a little bit. You could have still gone that way, but it would have taken a little bit longer than what you thought. Okay, number 24 is the same exact thing, but kiddos, what am I factoring in 24?
You think, can you take a difference of squares from the
I
bottom?
can take a difference of squares from the bottom. The top, I don't know if I can do anything to that because nothing's squared. It looks kind of like it's stuck. So I'm going to leave the top. But Luca, how could you tell that the bottom was a difference of squares?
Cosine of x plus 2, cosine of x minus 2.
Because the cosine was squared and the 4 was a perfect square, right? Now that subtraction in the middle is totally legal a factor. Why was that helpful? Yeah, I'm not killing a kitten if my entire numerator matches one of the factors of my denominator, right? And what do I end up with? 1 over cosine x plus 2. Now from the problem up above, some of you are like, oh, keep going. There's like a lot more that we can do with simplifying.
Problem is the 2, huh?
The problem is the plus 2. Cosine x plus 2 is tied together. It's a binomial. It's my entire denominator, right? So since that's one expression, I can't go doing secant or anything else. That plus 2 messes it up. So some of them are going to be pretty short. But you're getting your brain trained as to the math that you can do with these trigonometric expressions. What does it look like when I can factor? What does it look like when I have common factors I can pull out? What does a difference of square look like when I have trig involved? Does that kind of make sense? How about this one? There are 3 forms. Factoring a trinomial with a number in front. Do I have a squared and a single and a constant? Doesn't that sound a lot like a quadratic? Couldn't we maybe factor this trinomial?
But if we rearrange, I put the 6 cosine squared with the minus 6.
Well, you can try grouping, but I don't have 2 terms.
That looks like you can factor the 5 and 6, like it's regular x of x squared, like 6x squared plus 5x minus 6, but you just did that with the cosine squared of x.
And we could write it the other way, and we actually did this before when we had e to the, do you guys remember the e to the 2x? Could be 6 e to the 2x plus 5 e to the x minus 6. We would do that with exponentials. We can do it with trig too. We could let u equal cosine if we don't like the expression. We could write this as 6u squared plus 5u minus 6. We could ignore the cosine if you don't like it. But either way, whether you're looking at this or looking at that, either one needs to, you need to consider the factors of negative 36 that add to be 5, yeah. Whether you can do it with the cosine or whether you have to think about it without the cosine, you still got a factor. All right, cool kids, who found it already?
Negative 6 and negative 1. No, 6 and negative 1.
No, that doesn't multiply by 36.
Oh, 36. Well,
Yeah,
9,
4 and 9.
4.
A negative 4 and a positive 9, right? To get a positive 5. Now, couldn't we rewrite this? Now, guys, this U notation is really good and all, but we're in honors. I think we can do this. I'm going to rewrite the 6 cosine squared. I'm going to take this 5 cosine x and split them up, yeah? To be a negative 4 cosine x plus 9 cosine x minus 6, using that grouping that you guys already told me you like to factoring. No guessing check here. Now, Luca, now is it okay to group? Let's see if we have any common factors. Yeah. So then hopefully with some, let's pull out something that's actually in common, like a 2. Double check my math. I make mistakes too. We're agreeing? Take a couple seconds. Can you get there too? Are the steps making sense? Does the cosine mess everything up, or is it okay? It was like, I don't know, copy and pasted something. Green, I was like, ships? I didn't get it. Yeah. Okay, so what if it says simplify? Huh? Doesn't tell me what it's supposed to equal, that's okay. Can we plug in? Is there anything that we can substitute? Sine. Do a sine squared. Ooh, who's tangent? 1 over cotangent.
What is the sign of it?
Maybe. What's this Greek letter again? Theta. The red marker's not. Write it down. Snake. How do I do the math, guys? Does that make more sense? Now, can't I multiply across and get sine squared theta? Ooh. Now what? Yeah, I get a common denominator, yeah? You gotta follow the math. The math, I have 2 different pieces. Better get a common denominator. Now I have sine squared beta plus cosine squared beta all over cosine beta. This does not look any simpler.
Who is that?
Tangent.
Oh, that's 1.
Oh.
Hmm? Sine squared plus cosine squared is, that's supposed to be our favorite, right? Oh, we're done.
No,
No, we can
secants.
flip it.
What? No stinking way. That whole expression on top is really just secant. Okay, are some of the directions a little vague? Yeah, you still kind of got to think about the identities and how you can use them. However, think about the math. If I have fractions, multiplying across. If I have 2 different pieces, get a common denominator, put it together, and keep looking back at your identities, yeah? What else do we got? Don't worry, we still have 30 seconds. Do you realize I'm just doing lots of examples? It's homework help. This is what homework is. You're playing. You're playing with trig and you're playing with math. But wait, pause. Whoa, we have 20 seconds. How would you do it?
Just use each other. Just use each other.
Use each other, right?
Oh, I thought you meant like the like you helping each other.
Oh.
I thought you meant
Pause. Celebrating since you guys are packing up like 10 hours. Alright. So you can celebrate step 2, my darling. Wait. What are you going to do on the bottom?
Cancel.
What is the difference of squares? It's easy. Get out of here. Go play with trig tonight. I'll see you guys later if you have any questions.
Oh, it's Smile Monday.
Read it. Oh my God, that's a big deal.
That's good. We're just great.
So we can get it later?
Yeah.
Okay, so 4 o'clock?
Yeah. Thank you.
So, are we still going to do test fractions right now? Are we going to have time to do test fractions?
It probably won't be assignment.
Okay.
We might go over like this. Oh, we didn't have your sheet. Did I walk out and just do something? Yes. Because it's senior board. How long were you? Oh, just half an hour.